Here's a table of random numbers. Done some things with it. We'll talk about these things in order. The first thing we want to use this table to simulate a couple of, a number of things. Okay, so you should have read the instructions for question 7 and attempted it. And what you would get, and these instructions are pretty straightforward. I think everybody in class had no trouble doing this. You go down the second row and assign heads to any even number, tails to any odd number. Okay, now these numbers are random. They're generated by a random number generator in a computer, which is a pretty nearly random system. Okay, so we have 8 and 8 are both even, so they're heads. 3 is odd, that's a tail. 3 is odd, that's a tail, another tail. Now a couple of evens, so we have heads here and heads here, and an odd tail. And that gets us 8 outcomes, which is what was requested. Then we ask that you do the same thing using the fourth row and moving across. Now remember, columns go this way, rows go this way. I interchange those words unconsciously. So if you did the same thing, if you used a row where you should have used a column, or a column where you should have used a row, well, it's real easy to fix that. Okay, so anyhow, the fourth row is here. And what do we have? We have an even. I'll put a head on that. An odd, which would be a tail. Even, which is a head. Odd, which is a tail. Odd, which is a tail. Even number, which is a head. Odd number, which is a tail. And an odd number, which is a tail. So we have 1, 2, 3, 4, 5 tails and 3 heads. So that's a very easy way to simulate. Now some people started up here and went diagonally. This table isn't quite spaced perfectly, but we could see a diagonal pretty easily. So you could go down a diagonal and then maybe down to the next number and back up the next diagonal, then down to the number and down the diagonal, or any of a number of patterns that you could use to move through this list of random numbers. Okay? Now, another question. We simulated, and I think this is question number 8, we simulated dice. And the rule was, if we get a number that would appear on a die, we use that number. A 3 or a 2, a 3 or a 4 are numbers that could appear on a die. 9 is not, so we just skip that. We just ignore it. And then 4 is, maybe we go across this row. 1 is, 5 is, 7 is not, 9 is not, 2 is, 9 is not, 3, and so forth. Now, to do that, the rule that I chose to use, and you could use any other rule, of course, to do this, but I chose to go to the fourth column, go down that column. When we get to the end of that column, we go to the next column, and then to the top of the next column, and to the top of the next column, until we have 10 pairs of outcomes. So the first column, well, we have 7, 7, 0, 9. None of those are numbers that appear on a die. But then we have a 1 and a 4. So I've circled those, and I've circled those in green. We have a 1 and a 4. We can't get a 0, so we skip that. Then we have a 5 and a 6, and I've circled those in a different color. These are circled in green. These are circled in a combination of yellow and purple. Then we get a 7. Then we go to the top of the next row. We ignore the 7, but we get the 2 and the 3 and the 2. And the 3, skipping the 9 because it doesn't appear on a die. And we go on down doing that. We've got to go down 3 more rows and then another one before we can get 10 pairs. And then we add up each pair. So the first pair was 1 and 4. Well, that adds up to 5. Then 5 and 6. And look, the reason I use the different colors it is just to make it easy to spot exactly where the pairs are. So 5 and 6 gave us 11. 2 and 3 gave us 5. 2, 3 here again gave us another 5. 5 and 2 gave us the 7, etc. You should be able to see usually where these numbers come from. And I've written these numbers in the color that matches the circling of the pair. So what happened? How do we summarize these outcomes? Well, we could list all the outcomes 1 through 12. Now problem, the rest of problem 9 asked what proportion of the totals were 5, 6, or 7. Well, we had 4 5s, 1 6, and 1 7. Now I went a little further than that in making this list. I wrote the number of outcomes for everything from 1 through 12. So now we're getting an empirical probability. I don't have probabilities yet. I just have the numbers of outcomes. To get the probabilities, well, there are 10 outcomes, so each of these will be divided by 10. So the empirical probability is 1 over 10. I don't bother putting 0 over 10 because you still get 0. So if you got a 0, it's 0, even when you divide it by 10. So I'm just going to leave the zeros, but the non-zero results, I'm going to put them all over 10. Things get a little crowded down here. But these are the empirical probabilities. Now we know that the probability of getting a 7 should be higher than the probability of anything else, because there are 6 ways the two numbers could total up to 7. It just happens in this sample of 10 simulated rolls of 2 dice, we only got 7 once. We would expect to get 7 1/6 of the time. 1/6 of 10 is closer to 2 than it is to 1, but 1 time out of 10 is nothing unusual. Getting 5 4 times out of 10 is fairly unusual. We only expect to get 5 1 time out of 9, 4 times out of 36, and you should understand why that is. And we got it 4 times out of 10. You could do a binomial probability and figure out just what the likelihood of getting 4 5s out of 10 flips would be. It's not very high. BC of 10, 4 times 1/6 to the 4th times 5/6 to the 6th. But we're not doing that here. Okay, we get these results, and those are our empirical probabilities.